This will be a brief review over the energy topics that we have discussed. The first thing you need to know, and you just need to look back in your notes for this, is you need to know what gravitational potential energy, kinetic energy, elastic potential energy, sometimes also, I refer to it as elastic potential energy, but some people refer to it as spring potential energy, or you may see it as potential energy of springs, something like that. So you need to know those formulas. You also need to know the formula for work, and you need to know the formula for power. So all of these formulas are a necessary starting place for the stuff in the energy unit. So the first type of energy that we need, or the first type of topic that we need to discuss, is the energy transformation. Energy being transformed one to another. And the important thing here is that energy is conserved. Okay? So, since energy is conserved, it means that the energy initially in a system has to equal the energy finally in a system. Okay? What that means, it doesn't mean that, like, one type of energy has to equal the other type of energy, like word for word, straight transformation. For instance, from gravitational potential energy into kinetic energy. This can happen, but what more often happens is that you have several types of energies that you're dealing with. For instance, if I had a ball and I threw it down, and I wanted to know it's thrown from 10 meters up, and I want to know its speed at 5 meters, right? So it's halfway down. The way this formula would work, it wouldn't be this. Since it has an initial velocity here and an initial gravitational potential energy here, the energy initial will be those two things added together. Gravitational potential energy initial plus kinetic energy initial. And that gives you the energy initial right there. Then, on the other side, the final stuff, I've got to include the velocity here, again, and the height here. So at the end, it's also got a gravitational potential energy final, because it's 5 meters off the ground still, and it's got a kinetic energy final, because it's going some speed v. And so, you would have to plug in the formulas for each of these little energies to find the total energy of the system. And you should be able to use that to solve for height, mass, velocity, whatever it happens to be. I would also like to point out that if the situation arises where you do get something like gravitational potential energy initially does transform straight into kinetic energy finally, for instance, if you drop an object from 10 meters and it has no starting velocity up here at the top, then down here the kinetic energy and the potential energy should be equal to each other, right? So kinetic energy here should equal potential energy here, right? If that occurs, mgh should equal 1/2 mv squared, and if this is the case, the m's cancel, right? So be aware that masses can cancel, and that is an option. All right. The other thing that we've discussed is that energy changes in energy, rather, the change in energy is equal to the work. So I think the way I worded this was that energy lost or gained was equal to work, or meant work had been done. And so this is true. But the formula for this is this one right here. Change in energy equals work done. Now this could, if the change in energy is positive, then that means the work had to be positive, right? So if the change in energy is positive, it means it's going to, increase its speed, it's going to get higher, something like that's going to happen. Maybe the spring gets compressed. That means the work you did was positive. However, if the change in energy is negative, that means the work has to be negative because the force was taking something out of a system. So if you are trying to increase the speed of an object or raise an object up, that's when you're going to get this type of change in energy, a positive change in energy. And if you're trying to slow an object down, or friction, friction can slow the object down, right? Work done by friction is almost always negative, and so that would cause a negative change in energy, and you would have a negative work. All right. So let's just take a brief look at how the formula would look here. If you're trying to figure out the work done by something over a period of time. So let's say that, I'm going to make this a simple example, but let's say that you had a glider on a track, all right? I'm sorry for my drawing skills, but this is a glider on a track, and at this point it has a energy of, we're not going to worry about what kind of energy it has. It just has an energy of 100 joules, and here it has an energy of, let's see, energy. Here it has an energy of 50 joules. Okay, so the energy initially is 100 joules, the energy finally is 50 joules. And it went a distance of, let's say 2 meters from here to there. Now, one of the things you could do with this is you can find friction. So, like, if I want to know the frictional force, you could tell me this. How? Well, you should remember that the work done by friction should equal the change in the change in energy. You should also remember that the work done by friction should equal the force of friction times the distance. And so you're going to have to put these two things together to get the formula that you're going to use to find the force of friction. So what it's going to end up being is the change in energy is going to equal the force of friction times distance. The energy change was negative 50 joules, and it did this over a course of 2 meters. So you would get negative 25 newtons as your force of friction. Okay? So the two things that you need to know for the upcoming test are that the change in energy is equal to work, and that the energy initially equals the energy finally. And as a subset of this, you need to make sure that you understand that it's the total energy initially equaling the total energy finally. And so you may have to add up more than one type of energy like we did here. Okay? So that should be a good overview of the stuff that we have discussed. If you have any questions about this, the test is on Wednesday, so if you have any questions, you should probably come in and talk to me about it on Monday morning. All right?